Okay, I need to tell you about a mistake I made not that long ago that cost me a genuinely embarrassing amount of time. I was setting up a local AI coding assistant. I had the hardware, I had the time, I had a coffee, and a misplaced sense of confidence. I went to the leaderboard, found the model at the top, biggest benchmark number, most impressive SWE bench score, downloaded it, tried to run it, and watched my machine groan like I'd asked it to deadlift a truck. Model was 37 gigabytes of weights. My GPU has 24 GB of VRAM. The model didn't even load. It just sat there, judging me silently. What nobody told me, and what I had to learn by wasting most of a weekend, is that best coding LLM and best coding LLM you can actually run are completely different questions. The answer to one has almost nothing to do with the answer to the other. So in this video, I want to save you that weekend. We're going through the 10 best open source coding models right now, split very clearly by what you can actually run based on your hardware. I'll tell you which ones you rent via API, which ones you run locally, which one you need for autocomplete specifically, and exactly why picking the wrong model for the wrong job will frustrate you more than not having AI at all. But before you look at a single benchmark, you need to answer two questions. I say this because I skipped them and paid for it. Question 1, what hardware do you actually have? The 2026 landscape has shifted enough that this question has more nuance than it used to. A consumer desktop with a used RTX 4090 or a new RTX 5090 gives you roughly 24 GB of VRAM. That's your ceiling for local models. Apple Silicon Mac Studios are currently capped at 64 GB or 96 GB of unified memory due to supply shortages on the 128 GB configuration. If you want 128 GB of unified memory today, the target is the new AMD Strix Halo machines, the Ryzen AI Max plus 395 boxes, running around $3,999. A corporate cloud account gives you access to multi-GPU clusters. A laptop leaves you on the API. Each of these is a completely different category of model. The models that top the benchmarks need server racks. The models that run on a single 24 GB card are a different list entirely. Question 2, what kind of coding work are you actually doing? This one matters even more than most people realize, and it's where I see people go wrong constantly. Autocomplete, the thing where you're typing and the model fills in the next line, needs sub-second latency. It needs to predict the next token fast. If the model takes 3 seconds to respond, it's worse than useless. It breaks your flow. An agentic task, where you're pointing a model at a GitHub issue and asking it to write the fix, run the tests, read the error logs, and iterate, needs deep reasoning. It needs to plan across many steps. Latency matters less. Accuracy and tool reliability matter enormously. Refactoring a large code base needs a massive context window that doesn't forget what it read on file 1 by the time it gets to file 40. A model built for deep reasoning fails at low latency autocomplete because it takes too long to generate the first token. A fast tab completion model fails when you ask it to design a distributed system because it was never trained to think that deeply. These are different jobs. They need different tools. With that established, here are the actual models. Let's start with top tier the models that actually have frontier level capabilities. These models are extraordinary. They're also not running on your desk, but you can reach all of them via API. And in 2026, the price war between labs has made renting frontier open models cheap. First, GLM 5.3, built by Z AI specifically for long, multi-step engineering tasks across large repositories. What makes GLM 5.3 stand out is its 1 million token context window, and it actually uses it properly. Most models degrade in the middle of very long contexts, where important facts buried halfway through the input get quietly ignored. GLM 5.3 handles this better than most, which matters if you're pasting entire code bases into the prompt. It's a notable release because ZAI didn't touch the base model at all. It's the same 743 billion parameter MoE architecture as GLM 5.2, only 40 billion active per token. What changed is the post-training. More executable environments, broader long horizon tasks, and a lot more reinforcement learning compute. And the jump is real. Deep SWE went from 46.2 to 66.9. SWE Marathon went from 19.4 to 42.5. There was a lot of headroom left in that checkpoint, and they found it. Second, Kimi K2.7 code Moonshot built this one specifically for autonomous agent work. And I mean properly autonomous, not here's a function, fill it in, but here's a GitHub issue describing a race condition, fix it, run the test suite, read the failure logs, and iterate until it passes. The reason it can do this reliably is post-training. Instead of standard instruction tuning, Kimi K2.7 was trained extensively on trajectories of successful and failed compiler outputs. It understands that a syntax error is not a failure state. It's a signal to adjust and try again. That's a subtle but enormous difference when you're running multi-step agent workflows. 1 trillion total parameters, 32 billion active per token. Solid tool use reliability. This is your agentic coding pick. Third and fourth, DeepSeek-V4 Pro and Flash. I covered DeepSeek-V4 in a previous video, so I'll keep this one tight. The short version. These are the models that broke pricing for the entire category. V4 Pro costs $0.435 per million input tokens. V4 Flash, the smaller variant, is 14 cents input and 28 cents output. That's the kind of pricing where you can process millions of tokens of logs, documentation, and code for literally pennies. Bulk documentation generation, CI/CD pipeline analysis, anything high volume. DeepSeek is your default here. Both run 1 million token context windows under an MIT license. The Flash variant is especially interesting if you're building automated workflows that process lots of code at once. The cost is so low, it's almost academic. Fifth, Qwen3 Coder Alibaba's 480 billion parameter model scores 69.6% on SWE Bench, verified and operates under Apache 2.0, which matters a lot if you're building commercial products. Many open weight models have custom licenses that restrict commercial use or require reporting above certain revenue thresholds. Apache 2.0 removes that friction entirely. Ship it commercially without a legal review. Sixth, Kimi K3, the newest and biggest. Moonshot dropped the weights on July 26th, 2026, 2.8 trillion total parameters. 1 million token context window. Complex algorithmic reasoning, systems programming, compiler optimization. This is the capability ceiling of the current open ecosystem. It's also effectively API only for almost everyone on Earth because the hardware to self-host 2.8 trillion parameters doesn't exist in most budgets. But if you're calling it via API, it's remarkable. Now that we have talked about near frontier open source model, let's focus on model, which me and you can actually run. And this is where open source really pays off. No API bill, no proprietary code leaving your machine, no usage limits. And these are close enough to the frontier that for daily coding work, you often won't feel the gap. First, Qwen3 Coder next. If you have a 64 GB or 96 GB Mac Studio or a 128 GB Strix Halo machine, this is your primary local model. Because of 4-bit quantization, it runs on roughly 46 GB of unified memory. The mixture of experts design only activates 3 billion parameters per token, which means an 80B quality model runs fast on a good desktop without saturating your memory bandwidth. This is near frontier reasoning at local inference speed. For anyone with the memory to run it, this is the target. I did not expect a local model to be this close to what you'd get from a paid API a year ago. Second Qwen 3.627B, for solo developers on a 24 GB card, this is your daily driver. Alibaba released it in April 2026 under Apache 2.0, 27 billion dense parameters. Requires roughly 17 GB at Q4 precision, so it fits comfortably on a single RTX 3090, 4090, or 5090 with room left for context. It runs through Ollama for standard coding workflows using community ggwevs. One note here. If you want its native multimodal vision capabilities, you need the separate mproj vision file, and you'll need to serve it via llama.cpp or LM Studio rather than ollama. For pure coding text work, ollama handles it perfectly. Qwen 3.6 is the model I reach for most on my own machine day to day. It handles refactoring, code review, writing tests, explaining unfamiliar code, everything except the most complex architectural work. For that, I'll still reach for an API. But for 80% of my daily coding tasks, Qwen 3.627B handles it without a single token leaving my machine. Third Devstral Small 2, Mistral built this one specifically for multi-file, tool using work. 24 billion dense parameters, 256K context window, fits a 24 GB card at Q4 precision. The specific reason to reach for Devstral Small 2 over Qwen is tool reliability, specifically structured JSON output and function calling. If you're wiring a local model into a Python script that needs to execute shell commands, or building an agentic framework that expects strict JSON schema compliance, Devstral is more reliable here than most alternatives at this size. It's the pick for when you need rock-solid tool use rather than maximum raw capability. Fourth GPT-OSS 20B, and then there's this one, which I did not expect to be on this list when the year started. OpenAI released open weights under the GPT-OSS lineage. The 20B model has 21 billion total parameters, activates 3.6 billion per token, and requires roughly 14 GB of VRAM. It fits on a 16 GB card, which opens this up to a hardware tier that couldn't comfortably run most of the other local models on this list. What makes it interesting isn't raw benchmark performance. It's the reasoning style. The model generates an internal chain of thought trace, working out the logic of a complex algorithm before outputting the final implementation. For a model this size, that reasoning approach punches above its parameter, count on tasks that require working through a problem step by step rather than pattern matching to a solution. This is the OpenAI lineage on your own hardware, which is a sentence I wouldn't have written 12 months ago. Now I need to spend a minute on this because it's the most common mistake I see people make, and I made it myself. Every model I've listed so far is built for chat and agent workflows. None of them are the right tool for the task developers actually perform most frequently. Like tab completion, where you're typing and the model fills in the next line or block, requires a completely different training approach called fill in the middle, or FIM. A standard language model only knows how to predict what comes next based on what came before. FIM trains the model to predict the code between what's above and below your cursor. It sees both sides of the gap and fills it in. You cannot use a trillion parameter agent for this. It takes too long to generate the first token. You need a small, fast model wired directly into your editor, predicting tokens in milliseconds. The open answer to this is Codestral 2. Mistral shipped it in April 2026 under Apache 2.0 with native FIM support. You wire it into Continue Dev, an open source VS Code and JetBrains extension, and you get local tab completion that matches GitHub Copilot in quality, at lower latency, with no subscription. If you're on smaller hardware, Qwen3 Coder 14B is the alternative at roughly 9.5 GB at Q4. I ran GitHub Copilot for 2 years. I switched to this setup 4 months ago and haven't looked back. Now that sums up everything, and if there's one thing I want you to take from this video, it's to stop asking which model is best and start asking which model is best for your hardware and your specific task. Those are different questions, and conflating them is how you end up spending a weekend trying to load a 37 GB model onto a 24 GB GPU. I did that so you don't have to. The good news is that 2026 is the first year where the local models are close enough to the frontier that for most daily coding work, you don't feel like you're making a compromise. Qwen3 Coder next at 70.6 on SWE bench. Qwen 3.627B fitting on a single consumer card. Codestral 2 matching Copilot locally. The gap closed faster than I expected, honestly. If this was useful, smash the like button. It helps the algorithm put this in front of more developers who need it. Subscribe for more breakdowns like this, and drop a comment with what you're running or planning to run. I read every single one, and I'm especially curious who's moved to local inference and whether it's actually holding up for real work. See you in the next one.